Hi guys. Okay, for today's notes for this week, we're going to start talking about quadratic functions. And if you have been with me since the beginning of the year, we kind of dipped into this a little early. So some of this is going to feel like review. But if you don't remember it or haven't seen it, that's okay because we're going to see it now. So when we talk about quadratic functions, okay, the parent quadratic function, parent just means it's the most basic form of that function, looks like this. F of x equals x squared. Okay, that's the most basic quadratic function there is. That's why they call it the parent, because it's where all the other quadratic functions come from. Remember that f of x is just a fancy way to say y, so it would also be y equals x squared is how you'll see it sometimes. Okay, and what makes this a quadratic is that exponent. The x squared is what you're always going to see in a quadratic function. Okay, the shape of a quadratic graph is called a parabola. Okay, parabola is the shape of a quadratic graph. Okay, and there's a couple of different ways that we can see that parabola. One way looks like this. Okay, so this is a parabola that opens up, and that parabola has a minimum value. Okay, so if the parabola has a U shape where the arrows go upward, then we say that parabola opens up and has a minimum value. It has a lowest value. But a parabola can also look like this. Okay, so if we have a parabola that looks like a hill or a mountain, that parabola opens down and has a maximum. Okay. Now, there's a lot that we can learn from and a lot of information we can get from a quadratic function. Today, we're just working on what the graphs look like and what key features of the graphs are going to be. So what kind of things we are going to want to look for when we have the graph of a function. And then next week, we'll get into a little more into what we can do with them where we would need to be using the calculator. But today, we're going to be looking at graphs and identifying key features of those graphs. So what I want to do is take a look at this diagram, and we're going to label those key features that you're going to see on almost every quadratic function graph that you're going to look at. Okay. So this blue graph, that's our parabola, and there's a lot going on here. Okay. I'm going to start with this green point down at the bottom. This green point down at the bottom is our vertex. Okay. The vertex is the highest or lowest point on the graph. Okay, so depending on which way the parabola goes, the vertex can either be a minimum or a maximum. In this case, it's a minimum. Okay. So the minimum and the vertex are the same point. If this was a parabola that opened down, then that vertex would be a maximum. Okay. So you always find the vertex either at the very top or the very bottom of a parabola. Now, what you're going to notice on this diagram is that we also have this orange dotted line that's coming down through the vertex. This is what we call the axis of symmetry. Symmetry means that something is the same on one side as it is on the other. So the axis of symmetry cuts that parabola in half. It cuts it right down the middle, and it always goes through the vertex. Okay. So I'm going to make a note. It cuts the parabola in half. Okay. And it also goes through the vertex. Okay, so that's always going to be true about the axis of symmetry. So if you know where your vertex is, you know where your axis of symmetry is. Okay. Now, this point right here, kind of in purple, This is our Y-intercept. Okay, so we dealt with the Y-intercept a lot when we were dealing with linear functions. The Y-intercept is where the graph crosses the Y-axis. Okay, so the Y-intercept is wherever the Y crosses, wherever the graph hits our Y-axis. Okay, and at the Y-intercept, the X value is always 0, because remember the X value tells us where to move left or right. So the Y-intercept is always going to be 0, comma, whatever the Y value is. Okay. And then lastly, over here in red, we have the X-intercepts. Okay. That is where the graph touches the X-axis. Okay. And for our X-intercepts, the coordinates are always whatever the X value is with a 0 for the Y. Okay, so for your X-intercept, the Y is always 0. For the Y-intercept, the X is always 0. Now, the X-intercepts are special because there's a lot of different reasons that they're important, but what's interesting about the X-intercept is it actually has several different names. Sometimes they call it the X-intercept. Sometimes they call it a root. Sometimes they call it a solution. And sometimes they call it a 0. Okay, so X-intercepts, roots, solutions, zeros, those are all the same thing. Okay, so this point right here, sometimes I may ask you to find the root, and it's this point and this point. Sometimes I might ask you to find the X-intercept, it's still this point and this point. The solution, the 0, that's 4 different names for the same thing. Okay, so those are our key features. Remember that the shape is called a parabola. The vertex is either the high point or the low point. The axis of symmetry is an invisible line that cuts through the vertex right down the middle. The Y-intercept is where the graph hits the Y-axis, and the X-intercepts are where the graph hits the X-axis, and those are also called roots, solutions, or zeros. Okay. And this is where I want to say any questions, because normally we would clarify before we would move on. But like I said, as you're watching through the video, make sure that you are filling out the notes as you go, either sketching them in a notebook, or you can print the blank copy that I'm going to post and follow along, whatever works best for you. And then make sure you're messaging me with questions, letting me know if there's anything you struggle with, anything you need some clarification on. All right, so we're also going to do a few practice problems. Okay, so we've talked about what those key features are. Now let's look at actually finding those key features for given parabolas. Okay. All right, so if you look at the top, we're given a graph, and I just want to answer a couple of questions about this graph. So the first thing I want to know is, does this parabola open up or down? Okay, so the way we figure that out is we look at where the arrows are pointing. Okay, this one has it's got its vertex at the bottom, and then it goes up on both sides. So this parabola opens up. Okay, and for the vertex, I want you to actually give me the coordinates of this vertex. So here's my vertex. So if I start at the origin, remember that I'm going to give coordinates x, y. X is how I go to the left or right. Y is how I go up or down. Okay, so if I start at the origin, to get to that vertex, I'm going to go 1, 2 to the left, so that's a -2. And then down 1, so that's a -1. So my vertex is at -2, -1. Okay. Then I want you to be able to tell me, is that a minimum or a maximum? Well, I just have to ask myself, is it the lowest point or a highest point? And this is obviously the lowest point of the parabola, so it is a minimum. Okay. The axis of symmetry, we talked about on the page before that the axis of symmetry always goes through the vertex. So if I draw an invisible line, well, I'm going to show it as a dotted line. That's my axis of symmetry. Okay? The axis of symmetry always has an equation of x equals a number. Okay? And what we're looking at is, where would this axis of symmetry cross through the x-axis? Well, it's going to hit here at -2. So x equals -2 is our axis of symmetry. And what you are hopefully noticing is I had a -2 in my vertex and a -2 in my axis of symmetry. Those are always going to be the same. The x-coordinate of the vertex is always going to be the value we use for the equation of our axis of symmetry. Okay. So now we need to look for our roots or zeros or solutions or x-intercepts. I wrote all those names because they're all the same thing. I have one here and I have one here. Okay. So my solutions are at, I'm going to start at the origin. I'm going to go back 1, 2, 3. So I have one at -3, 0. That's this point here. And then I also have one at -1, 0. So those are my solutions, -3 and -1. And then the last thing I'm looking for is the Y-intercept. Okay, so where does my graph hit the y-axis? Well, here's my y-axis right here. So my graph hits here. So I know that my x value is 0 because I don't move left or right. And then I'm going to go up 1, 2, 3. So 0, 3 is my y-intercept. Okay, so I'm just going to label those on the picture as well. This was -2, -1. That was my vertex. My minimum was, minimum is my vertex. Axis of symmetry goes through that. And then my zeros were at -3, 0 and -1, 0. And then finally, my y-intercept was at 0, 3. Okay? I know that's a lot for just one graph. Okay? So let's look at a couple more examples. So the second example you'll notice that it has an equation on the graph. Ignore that. That was just the image that I used, and it was easier to just put that on there. There's a lot we can tell from this equation when we get to that point, but right now we're just looking at the parabola. Okay, so the first question is, does this parabola open up or down? Well, this parabola has a highest point, and then the arrows go down from there, so it opens down. Okay. For the vertex, we're looking for either the highest point or the lowest point. So that's going to be right here. And the coordinates for that point are 1, 2. Okay. And since this is the highest point of the graph, this is a maximum. All right. The axis of symmetry always goes through the vertex. So I'm going to go ahead and sketch it on the picture. And then the way I write it is with the equation x equals wherever that invisible line would hit the x-axis, and it hits right here at 1, x equals 1. And so you'll notice again, the vertex has an x-coordinate of 1, and the axis of symmetry has an equation of 1. That's not a coincidence. That's always how it's going to work, because our axis of symmetry always goes through the vertex. Okay. Our x-intercepts, also called our roots, solutions, And zeros, we have 2. We have them here and here. Okay. So we have one at -1, so that's -1, 0. And we have another at +3. So that's going to be +3, 0. And then lastly, our y-intercept. So our graph hits the y-axis right here. Now that's not exactly on a perfectly whole number, but it looks like it's about halfway between 1 and 2. So I'm going to say my x-intercept is at 0, 1.5. Because it looks like it goes about halfway between 1 and 2, so that would be 1.5. All right. So now we have one more to do. What I would recommend you do is pause the video and then try it on your own. See if you can identify them. This would be the you do part of the notes if we were in class. So I would have you try this one on your own and then we'd come back and talk about it. So go ahead and pause the video, work through that one, and then start the video again and see if you got the same thing I'm going to put down here. All right, this parabola opens up because that's the direction that my arrows are pointing. It has a vertex right here at 0, 2, 3, 4, -4. Okay. This vertex is a minimum because it is the lowest point on the graph. And the axis of symmetry goes through that vertex, goes through that minimum. And has an equation of x equals 0. So again, x equals 0, vertex has an x of 0. That's always going to be the same. Okay. The roots, 0 solutions, x-intercepts, those are these points right here. Now I'm going to approximate those. They don't land exactly on those points, okay? But for today, we're just going to approximate those. We're going to estimate. It looks like it's at about 1, 2, 3, -3, 0, and +3, 0. Now I realize those aren't perfect, but we're going to get really, really close with that number. And then the y-intercept is where we cross that y-axis. This one crosses at -4. Okay. So for this particular graph, the vertex and the y-intercept happen to be the same point. That's not always going to be the case, but it is going to happen whenever the axis of symmetry is the same as that y-axis. Okay. Now, one thing I forgot to talk about is that you might see on the practice quizzes is when we're looking at a minimum value or a maximum value, I want you to actually give me a numerical value that goes with that. So the minimum in this case is how low does the graph go. So what we're looking for is the y coordinate of that vertex. Okay, so the lowest this graph goes is right here at -4. So our minimum for this graph is equal to -4, and what you're going to notice is that happens to be the same as the y value of the vertex. Okay, let's go back and look at our other two examples and see if that still works. I'm going to come up one. The maximum value, the highest point on this graph, is right here at 2. So the maximum is 2, and looky there. It is also the same as the y value of our vertex. If we look at one more, the very, very top, the minimum, the lowest this one goes is -1. So again, that minimum is always going to be the y value of that vertex. Okay. Now, one thing I'm going to add, and I'm just going to kind of add this at the bottom. I didn't print it out for you, but make yourself a little note down here. These three examples all had 2 roots, 2 zeros, two x-intercepts, two solutions. Okay. There are actually three possibilities when you're asked about solutions or roots of parabolas. Okay. So one situation is this. Okay. This is what we've seen so far. We have our axes, and we have a graph that goes through the axis and then back again. Okay. This graph has two solutions because it hits the x-axis twice. Okay. So that's one possibility. Now there's another situation that might come up. You may see some that look like this. You may have a parabola that comes up, touches that axis, and then goes back down again. Okay. If that graph only hits the x-axis one time, then it has one solution. Okay. So you might see them with two solutions, you might see them with one solution, and there's one other possibility. Last thing you might see is something like this. You may have a parabola that comes down and goes back up without ever touching the x-axis. This would be a no solution. Okay. Oops, sorry. So these are the possibilities. You're either going to have two solutions, one solution, or no solution. And the way you figure that out is by looking at how many times that parabola hits that x-axis. Okay. Like I said, watch this video as many times as you need. If you go through the notes, go through the video, and you're still aren't understanding and you want some additional resources, please message me or log into a Zoom. We can either do a Zoom conference where I actually work through the notes with you. I can find some links to some other videos maybe that have a little bit different explanation. Whatever works for you, just let me know what you need. I miss you guys. I hope you're doing okay, and I hope to hear from everybody this week. Talk to you soon. Bye-bye. You won't have a problem. Wait.